easier to buy and sell your home. And among other things, what we do is that we are able to make the process of buying and selling a home much faster by using machine learning and data science. And so a process that normally takes 60, 90, 100 plus days, we can do in a much shorter time, on a matter of days. Background about me. So let's see. I joke that I've been doing data science and machine learning since it was before it was called that.
It was
Sorry?
Stone Ages.
Yeah, Stone Ages, basically, right?
It was like 2000, 2002, right? Somewhere there.
I think probably older, probably before some people were born on this call.
Yeah.
Which I don't want to
most
go
people.
on.
Most people.
Yeah, I was not good. Thank you for making me feel old. Yeah, so since the Stone Ages, basically. So worked a lot on the Human Genome Project. This was about sequencing the DNA for humans, for the human genome, mouse, rat, etc. So this was in the early 2000s. Was originally intended to be a research scientist. I think I would have been a pretty good one, but ended up getting recruited by Amazon. Ran engineering for Amazon personalization for several years. I was good and knew I was good, and slightly cocky as a result, and thought I could do more, despite I think a lot of the opportunities that Amazon presented for me at the time. Decided to start two companies. One worked, one didn't, is a short version. And let's say both of those companies were, let's say, very, a lot about data, a lot about understanding deeper statistics and using that in some way to help everyday people. I think a lot of tech companies do things for like the top 1% or 0.1%. That's just not something that
right.
I care about helping a lot of people, working for a lot of people. I've been an advisor at various points. So I was an advisor at Airbnb and Opendoor before this, before joining full-time, probably 10, 15, 20 companies in total. And was an advisor at Opendoor for about I forget the exact number, about a year before joining full-time in November.
Yeah. So Kushal, like if you would go back, to the early days, like imagine today, you were 17-year-old, right? And I want to really ask this question because I think it's relevant, to the folks here. You sort of like triple majored at UC Berkeley, right? And they seem to be also quite diverse majors. One is biology, cellular biology, and the other one would be computer engineering and also computer science. So like can you talk a bit about your college experience? Like, how did you decide your major? In retrospect, did you think you made the right choices? What would you do differently?
Yeah, that is a very big question.
Yeah, sorry, it was three questions.
That's a bad thing. So why don't I give like the top level, and then we can talk about anything. Yeah. I'm pretty much an open book. I'm happy to talk about anything or everything that is interesting for folks. How did I make that decision? First of all, for the record, I do not advise anyone to take the sort of educational career that I took, or educational trajectory that I took. I almost failed out of high school. I had like a 2.9. I was in remedial math for a bunch of time. I had two teachers who really all but physically kicked my butt into shape, and that's the only reason I have this job today. That's the only reason I got into college, etc. My pitch to Berkeley at the time, so they had these grids when I was applying, which is like your SAT score and GPA, given that there's a probability of getting it. Mine was 3%. And I didn't know this at the time, but I was basically doing expected value, so I applied to something like 30 schools. And my pitch was basically, I really, really screwed up. I won't do it again. I promise. I'm not an idiot. I had taken like 12 APs or something, got fives on most of them, including ones that were not offered at my high school. Here's evidence that I'm not an idiot. I won't do it again. I promise. Please let me in. And Berkeley bought it. But highly atypical student in a lot of ways. Probably wouldn't work these days, quite frankly. Even if it did, I would not recommend this, if for nothing else, for the stress that you would cause your parents and yourself. It's not a reliable strategy for success. At Berkeley, kind of stumbled on this by accident. There's a short version. I was in the College of Engineering, and the College of Engineering at some point told me, hey, Kushal, it's nice that you're taking all these philosophy classes, but you're in the College of Engineering, you need to take an engineering class. Reasonable. The class I took was Introduction to Programming with MATLAB. And the best way I can put it is I was like love at first sight. I was not a good enough student in high school to take computer science and didn't, etc. Didn't know modeling existed, didn't know statistics existed, but had kind of always seen the world in a slightly different way. Which is to say, I saw the world in numbers, and I got bullied a lot in high school and middle school as a result of that. And it just clicked. As soon as I took the class, it was like, oh, this is what I've been put on earth to do, basically. And I think, like if I had one piece of advice, if I think I've done one thing, like, is that right in my career, and there's a whole bunch of luck involved with this, which is finding something that I was good at, that people were willing to pay for, and that I enjoyed doing. There's a notion in I'm going to get the word wrong, so I actually won't get into it. There's a notion of like these 3 or 4. There's a lot of things that people are good at. There's a lot that any one person is good at. There's a lot of things that they enjoy. There's a lot of things that people will pay for. And if you can find something that meets all 3 of those, you're really, really lucky. And I was really, really lucky. But you need to find at least, in a perfect world, someone would get all 3 of these, and that's fairly lucky. You don't always get that, but like, you need to find something that has at least 2 of those 3 things, or 3 of those 3 things to really be, I think, be happy in one's career. And that's one thing I did right, I think.
Yeah, that's fantastic advice. Actually, that's very similar to the kind of philosophy that we teach to our students, which is basically using data to make decisions. And you talked about, for example, those 3 different criteria. There, we have actually 7 different criteria, and the ones you listed is actually the major 3 criteria. Yeah. So
that's awesome.
Yeah. So when I look at, for example, like your life at Berkeley, you published also at peer-reviewed papers, right? Peer-reviewed journals, and but somehow you chose not to go to the research route or academia route, right, in natural sciences, but instead you went to Amazon, right? And I can, what you wrote in Amazon was extremely impressive too. And I wonder, like, like how did you chose that route? Was that by accident, or you did some research on that? Like, how did you decide on that?
Yeah, complete accident. I didn't want to go to Amazon. One of my friends had interned there, and basically forced me to send him a resume, forced me to interview with them, forced me to go with him on the cell trip, and then at some point it's like, oh, this is actually kind of cool. So like literally, like I was a research scientist, and still think of myself as a research scientist, and that was the original trajectory. And thought of interviewing jobs, etc., as a distraction at that time.
Yeah.
And this guy is like, hey, just send me your resume. Like, what's the worst that could happen, right? You're in an interview, whatever, right? You do the interview. Same thing with the interview. I got selected for interview, and like, hey, just interview. What's the worst that could happen? Got the offer. Just come. Amazon's paying for like a end-day trip to Seattle to just check it out. Like, worst case, you get a vacation. What's the worst that could happen? And the next thing I know, I'm sitting at a desk in Seattle. There's this notion of, I think anyone who's successful, I think if they really think about it and are honest about it, there's a huge element of luck in it. That's not to say it's all luck. Like, I've obviously worked very hard and continue to work very hard. But there's, I think, this notion that I'm going to maul the quote, but luck plus the prepared mind is what equals success. Absolutely not the quote, but that's something like the quote. And so I was prepared. I saw what ended up being the opportunity, and I took it. And I think that's always something you have to be open to in your life. You have to have the plan. Like, not having a plan is a solid way to not be successful in whatever way, or not be happy in whatever ways that is important for you. but you also have to be willing to look at the plan and say like, oh, interesting, I didn't expect this. There's always something unexpected that happens. But this actually gets me to what I think I want in a faster way, better way, safer way, etc. And I think that's how Amazon played out for me. To answer to the more specific question, I think Amazon was an incredible opportunity for me because it was the same sort of work. It was the same, again, but I think in research, like at best, you can hope for, if you do something really amazing, at best in computer science, you can publish a paper in like 6 months or 12 months. Like that's roughly how long it takes to know whether something worked.
That's even you're lucky. Yeah.
Yeah. So that's optimistically, right? And at Amazon, like I'm really proud of what my team did, but it wasn't crazy. Like what we were able to do was like go from like literally crazy idea in the shower to like a customer, like a test in front of like an A/B test in front of customers. Happy to talk about A/B test if folks don't know what it is on the call. A/B test in front of customers in like 2 weeks, which doesn't happen. It's a top, it's like a top 1 percentile to 3 percentile achievement, but it's not crazy. And I was never going to be able to go back from a 2 week, like knowing if an idea was right in 2 weeks to a year. I was just the kind of person I am that it was never going to happen.
Mm-hmm. Mm-hmm. Now, one thing I really wanted to understand here is when you look at your experience at Amazon, not only is technical, but it's also leadership, right? You mentored a lot of people. Obviously, you led the design architecture of the recommendation engines. I'm very curious about, back in 2005, 2007, for example, the recommendation engines, like what was the kind of system at the time at Amazon? But I'm also just personally, I'm so curious, is like, how did you train yourself to be a leader, right? Because literally you graduated from UC Berkeley 2004, and right at 2005 to 2007, you were leading a huge team. What are the things that you sort of like you did to prepare yourself for that?
Yeah, that's a great question. It requires me to talk a little bit more about Berkeley. So, again, I have a very atypical educational background. So I discovered this class, like let's say my probably like late freshman year of college. And I'm the type of person, if I get excited about something, I am all in. You can't stop me. I will blast through brick walls. Mm-hmm. And this applies to everything, not just AI. It's like, I triathlete. And when I discovered triathlons, like I was just in it. You couldn't stop me. I was doing Ironmans in like a year or something. And that's just the kind of person I am. That's just how my brain works. And at Berkeley, so once I took this class, I was like, this is it. This is what I've been here to do. So I finished both my majors in the first 2 years and basically spent the last 3 years of my college career just doing research. So I had I was working on actual research papers and with actual like professors, and I was taking every grad class I could find in this field that didn't yet exist. And so when I graduated, I effectively had like 2 or 3 years of experience already. It doesn't, again, very atypical background. And I remember getting to Amazon, and that's actually even the leadership part. Like I got bullied a lot in middle school and high school, and just was very shy, socially anxious, didn't just and then at Berkeley, again, I was good at this, and just in projects and classes, like I realized people were like looking to me for something. It was a very different look, and like I didn't quite get it, and I realized at some point that they wanted leadership. They wanted someone who would tell them what to do, basically. They knew what I was doing was working, and so they wanted to do more of what I was doing. And it was really weird, and I didn't get it. And this was an extreme, like, very different experience than what I had in high school, where I just got yelled at and bullied at, beat up on a regular basis. So I think the journey for me started there. I think at Amazon, the way I kind of did this transition, I think it was happened in 2 ways. One is, you join out of school, you get a project. The project is usually, something small, something like kind of it's like on training wheels, right? And I remember looking at this and was like, okay, this is dumb. I'll do this. You asked me to do this, but this is, in my opinion, dumb. But I'm also going to do something else on the side. And it was something that I was excited about. It's something that I think made a lot of sense for the company, and it ended up working. I'll spare the details. And I think people were really astonished, and it kind of just like set out, like, hey, this guy's a month in and like coming up with ideas and building the idea that no one else has done. It's a way to make a mark, right? And I think the same thing started happening, which is that even well before like I had any official promotion or anything like that, I think people were looking to me for guidance and leadership. I think that is actually a very important skill, and that's something I continue to, I'm a much better leader than I was back then, but it's something that you still continue to learn every day, and something that you practice every day, not something you just learn once and get over with.
Right.
But I think working with other really smart people, I think it kind of builds it out of you. Like I had coaches, I had mentors that really took me under their wing to really teach me how decisions were being made at the highest levels of the company. I proactively asked for other mentors to really understand how I should, like the culture at these sorts of companies is different than what I've grown up with. I've grown up in a somewhat lower middle class context.
Yeah.
And so learning the etiquette, learning how to have these conversations, having mentors who trusted me and believed in me, were, I think, really all the important things of kind of like making that transition.
Yeah, that make a lot of sense. I'm curious. I'm pretty sure also, folks, like teachers here, they are very curious, about, for example, like you have done quite a bit ML right in the beginning, right? And I was wondering, is it possible for you to talk about, the kind of systems, at Amazon, like for recommendation system? Is it possible that, we can learn from you in 5 minutes, like how the system would work back then?
Yeah, sure. I don't know
So people know
what level of detail should I?
Yeah. So people here, they know what is supervised machine learning. They know what's unsupervised machine learning. They know logistic regression. They know tree.
Okay.
So some of them they know actually deep learning as well. But I'm pretty sure at the time, 2005, 2007 ish, deep learning is not there yet. So I'm just kind of curious about, like inside a company, not just the algorithm part, but it's like life cycle of data, engineering systems, So
Yeah, sure.
yeah, talk as if you're trying to sell a position to these young folks. Yeah.
Yeah. Okay. That's a great question. I obviously can't speak to current because it's covered under like a lot of restrictions and et cetera. But I can't speak to something that was like now 15 years ago. I think the main point is that it doesn't actually matter about deep learning versus logistic regression versus collaborative filtering, whatever. I think what really matters is understanding the fundamentals. And so I'll explain it at the fundamental level, and then I can put in some of the details as maybe helpful. So recommender engines at Amazon were founded, and I was like part of the early team that helped build this out. Can't take credit for being the person who invented them, but let's say I was the second or third lead on the team that drove this. The fundamental observation of founding, like the first recommender engines at Amazon were, what correlations do we see between purchases that are unexplainable by random noise? That's all it is. Everything else is details after that. So if I know that 2 books are being bought by customers at X rate per week and Y rate per week, what is the probability that I would expect to see them being bought together at Z rate, right? And if Z, you can do the math, etc. If Z is much greater than what you would expect randomly by X and Y being bought together, bought separately, then you say that, hey, there's something interesting here. There's something weird going on that I can't explain. And I claim that this is worth showing you because that's often an indicator of a deeper relationship.
Sure.
There's a whole bunch of stuff after that in terms of p-values, in terms of like collaborative filtering, in terms of how you calculate that. But again, those are all details. I'm going to come back to this because it's actually really important, like how you think about modern ML. And so given that observation, the question becomes like, how do you now build this end-to-end thing that actually works, right? So we obviously have the purchase data, and so we could see like what the independent rates would be. You can do a stage, like calculate all the pairwise correlations that are unexplainable by random noise that are at sufficient volume that meet certain criteria that like a G-rated book should never recommend an R-rated book, stuff like that, things that you would imagine. And so you now have this set of relationships now. And so now the question becomes like, how do you, for an actual person, which is not a relationship between items, for an actual person, how do you generate this in a way that is fast enough, basically, and accurate enough? To give you an idea, the sorts of things that we talk about here are latency, which is how long does it take from the time that you make a request to the time that it is shown, like what is the number of milliseconds, or in this case, milliseconds, between the beginning and end. And the second is a notion of 2 nines or 3 nines or 4 nines measure. So like one way of measuring latency is the average. Turns out it's actually a really bad measure in a lot of cases like this. And so you instead ask the question like, on average, so not on average, like if I look at 1,000 requests, what is the worst 1% of requests that were responded? That's considered like a 2 nines, it's 99% obviously, 2 nines latency measure. So we're talking about 2 nines, 3 nines, 4 nines SLA, 2 nines, 3 nines, 4 nines requirements of response in like 300 milliseconds, roughly, is what we're talking about. Just say quite fast, actually. So how do you do this calculation for hundreds of thousands of people in the worst 1% of cases responding less than 300 milliseconds? Now, how do you just do this, right? It turns out the way that we did this that worked was that we can look up someone's purchases very quickly. It's like something that takes 10 milliseconds. Let's say they have like a couple thousand purchases, a couple hundred, whatever. For each of those, you can, so this is like, let's say, background information retrieval. 2 is given the background information, generating all sorts of candidates, which is now looking at any individual purchase. What are those disproportionate relationships that are unexplainable by random noise? So generate a bunch of candidates, score them. So now, like, given all the information that we have about this person, given the relationships, let's score any one item. And then 4, let's filter them for things that they bought in the past, things that, et cetera. And so it turns out that you can do all of this on average in like 100 milliseconds, let's say. And we don't have to get into the details of 3 nines and 4 nines, but like basically occasionally would allow for mistakes that would take a couple hundred milliseconds more, basically.
Right.
There was one point that I made there that's really, really important that I wanted to come back to, especially for this audience. So there's a lot of advances in AI, ML technology, but I think the one thing I would emphasize over and over again is that the fundamentals are what matter. Knowing logistic regression is nice and it's important, but you need to understand why logistic regression works and why it doesn't work, because there's going to be lots of cases that it doesn't work in, and you need to know when to choose something versus the other. Like if you think about like at a very deep level, in my opinion, like humanity is kind of distinguished from other species by like building tools. And, like the classic example is like, apes invented like being able to put a stick into an anthill and pull out ants, right?
Yeah.
But that's a stick. It's not a tree branch, because if you use a tree branch, you put in an anthill, the anthill would break.
Right.
And so the same thing applies to logistic regression. Logistic regression is just the fancy version of this stick you stick into an anthill. And so really what we are distinguished by as Homo sapien species is knowing what tools are good for which jobs. And you can't do that unless you understand why certain tools work in certain ways. And you can't do that unless you understand the fundamentals. So specific tools are very different now than they used to be 15 years ago, but the fundamentals are still the same. P-values work in the same ways. Central limit theorem works in the same ways. Those are the things that especially at this stage, that are really, really important to understand.
Yeah, for sure. I can't help it, but also like wanted to ask you this question, just to build up on what you said. Looks like we have to look into each algorithm, understand, why it works, how does it apply to different scenarios. But the system you just talked about, for example, having that kind of, matrix, right, or building, those candidates, whatnot. This sounds like incredibly like, complex data engineering problem as well. So can you talk a bit about like, engineering versus data science? How should one, prioritize one versus another? Is there a way to prioritize, or should we get good at both? What's your strategy, to be the best?
Yeah, you mean in terms of personal skills, or do you mean in terms of like a company?
I would go at personal skills first. Yeah.
Yeah, great question. So I would say data as a whole breaks down into three fundamental sub-disciplines. One of them is data engineering. One of them is, let's call it analytics. And another is, the third is, let's say, modeling.
Right.
When most people talk about data, what they refer to as the third one is the modeling, machine learning, deep learning, etc. The other two are equally important, I think, is a short version. And you can't really do one without the other. And if that means you're on a team and someone else is doing it, maybe that's fine. But realistically, you're still going to have to understand at least some of it. You're probably going to have to do at least some of it. So you need to understand all of it, basically. You need to be able to ask the right questions, etc.
So sorry to interrupt, but could you actually tell the students a little bit, like, those three things? How does that, directly apply to the Amazon case?
Yeah, sure. Yeah. Maybe I should even go one deeper on what each of those mean. So data engineering is, I kind of have my shorthand, but that's not appropriate here. Data engineering is, I'll just go with the shorthand because is plumbing. It's about setting up the pipes to get raw data from one place to measure the right data and put in the instrumentation, have the right tracking, capture the right fields, make sure you don't have data corruption, and then putting in the plumbing to get it into tables in the right ways, in the right format, make sure you don't lose things, make sure things don't crash, blah, blah, blah.
Right.
Analytics is about graphs, basically. I'm being grossly reductionist about all this, but roughly. Analytics is about understanding the world and measuring what matters, and understanding what things drive of what matters. So for example, like at Amazon, what matters is conversion rates, like of the number of the, like let's say 1,000 things that I showed in the last hour, how many of those things did people actually buy? And the numerator divided by the denominator is conversion rate. But then, that's fine. You need to measure that. But then the question is like, what drives conversion rate? And what drives conversion rate is relevance. Like, is this thing actually relevant to you? Is it trustworthy, etc. And so understanding that and understanding how to measure that, you can keep going. Like you can keep going, going up, basically. And that's analytics. 3 is modeling. Modeling is predicting the future. It's fundamentally what it comes down to, in different ways, in different things, etc. But fundamentally about predicting the future. I think this is the most obvious one, so I won't necessarily go into too much detail here. How does this matter? How is this relevant at Amazon? I can't get into specific numbers, but there were hundreds of millions of items in the Amazon catalog at this point. There were hundreds of millions of customers buying things, and there were billions of interactions. You have to have a very, very tight, very, very strong data pipeline, because again, the plumbing analogy works, because if you're leaking even 1%, you are dropping hundreds of millions of pieces of information, and that is not good. So data engineering problem, how do you get this data that is being purchased on the website into formats that we can use, ingest them in the right ways? How do you calculate, if you did this naively, if you looked at all 100 million, like, if you think about the like number of relationships, right? If there's like 100 million items that could be matching with another 100 million items, I'm not going to do the math, but there's a lot of zeros at the end of that, and every computer would crash even today if you try to do it naively. And so how do you do this calculation, basically? That's the fundamental thing. The modeling part of this is, given, like in this case that what you're trying to predict is this item relevant to a person? So you're trying to predict relevance, basically.
Yep.
And at the the way I explained the original point was that you're also trying to explain, to decide what is not just relevant for a person, but what is relevant for this particular item. Like, what are all the other items that are relevant? And this is fundamentally a prediction / modeling problem. Analytics then becomes kind of the example I already gave, which is, hey, we want to track conversion. That's clearly what matters to the business. But then what drives conversion, which is relevance, trust, and non-obviousness, roughly three things that matter for recommender engines. Like, how do you decompose that further, et cetera?
Yep.
So,
awesome. Yeah.
So I can stop there.
Oh yeah, this is great example. Like, the kind of thing is, you have so much interesting, like, experiences. I want to definitely get to Vidana, the one where you were helping students with microloans. And it sounds like after Amazon, you have been essentially in the startup world, building like small companies, two of them. Can you talk a bit about like, let's focus on your experience at Vidana. Like, how did the opportunity come around, and how did you sort of use data to grow the company?
So Vitana did student loans in developing countries. So imagine someone who wanted to be a nursing assistant in Rwanda. It turns out that paying for those classes is actually quite hard in basically most countries except the US, because student loans aren't available. Student loans are obviously have a very mixed reputation here, but the fundamental concept is quite empowering, that you can get an education and pay for it with your future earnings, basically. And that just fundamentally doesn't exist in most places.
Right.
The opportunity, for, I think, startups, the opportunity doesn't really come around. It fundamentally is like something that you have to make happen. So I had left Amazon by this point. Given some of the history that I mentioned, like I had a couple of teachers who were really, I think, foundational in my life, and I would not be here without them. Like, education is something that always had mattered to me, fairly fundamentally. And Dr. Yunus had just won the Nobel Prize for microfinance, and given my background, given my experience with education, how formative it had for me, like I asked the question of like, hey, why don't we do microfinance for education? And everyone told me it was stupid, and I disagreed. Like, I knew how much education had been pivotal in my life, and I was like, you're wrong, and I don't see anyone who's going to do something about it except me, so I guess I'm doing something about it now. Right. I started this company with my co-founder, who happens to be my best friend, was the best man at my wedding, also was the single best engineer I'd ever worked with at Amazon, or ever happened to be at Amazon. He and I started together. He has a similar story. He came from the South Side. He came from a not great neighborhood in Chicago. And we both knew how important education had been in our lives, and we wanted to do something about this. And we hired a team, raised a bunch of money, and did it. So ultimately was, I think, quite successful. We had operations in 17 countries. We're doing about $25 million worth of student loans every year, about 1,000 students a month rather. Yeah. Ended up being quite successful. Ended up merging with Kiva 4 or 5 years ago.
Right. So can you talk a bit about like the data operation inside more startup? Because and contrasting to what you experienced at a larger company where probably data engineering was taken care of. I could be wrong.
So data is a weird thing. So we built very fancy, great portals for people to apply, et cetera. And we saw these, like, when you look at any data usage pattern for pretty much anything, like humans follow circadian rhythm, like there's a very standard chart that you see, which is like people wake up somewhere between 6 and 10. You see this curve like spinning up. It sort of peaks around like 1, and then kind of like dials back down to again by like 8 o'clock or so. So we built these beautiful portals for people to apply, et cetera, and we weren't seeing these sort of like standard circadian rhythm that you would expect. We're seeing this like really weird, like just spike, and spike, and then spike.
Interesting.
And it's like, well, what's going on here? So we operate in developing countries. And I don't know how many people here have visited India, Rwanda, Peru, et cetera, type places, but it's a little different, right? And again, it's also different now than it used to be 10 years ago. So these portals that we built were not being used. Basically, what it turned out was that the branch officers of people of the local banks that we partnered with were printing them out in triplicate, making 1,000 copies in their Xerox, putting on a motorcycle, driving 2 hours to a dusty village, filling it out by hand, and then coming back and then typing it in. So these were the spikes that we were seeing, right? Because there was someone just typing in 100 applications. And data starts getting really messy and really complicated when you start doing things like this, because like whenever there's a human involved, like humans are error prone, humans are unreliable, I'm unreliable, I'm error prone, everyone is, right? It's just a fact of life. And so you have lots of really messy data. People type out the word TWO as opposed to the number 2, which obviously creates havoc in data engineering rules downstream. So it was a mess, as a short version. And it kind of goes back to like, you can talk a lot, you can talk for years about different underwriting rules and models for risk and things like that. But ultimately, it doesn't really matter until you can like get the data engineering right. And we were able to do a lot of the more sophisticated stuff, but I would say like the first years were just about like hey, how do we just get this data in a way that we can do anything with, basically?
Mm-hmm. Mm-hmm. Yeah, awesome. So we have so we've been talking for 40 minutes, and I don't want to, for example, occupy all this time. I have one more question to ask, but then maybe afterwards we should just turn to the students, and they can ask whatever questions they want to ask. Yeah. So I have a question, which is like, when I look at your bookshelf, it's very diverse, right? So you have engineering books, you have design books, you have product management books, and even chemistry. So I was wondering, like when you're thinking about building up your skill set, like were you, for example, deliberately, build it up, or were you, for example, maybe just pick up whatever that's interesting?
Yeah, that's a great question. I think it's really dangerous for people who are further in their career to say that, oh, hey, I had this master plan. It all kind of proceeded to the master plan, because it just doesn't. That's if anyone tells you that, they're just lying, quite frankly. My favorite quote in this context is the Mike Tyson quote, which is that everyone has a plan until they get punched in the face.
Sure.
And everyone gets punched in the face. It's just life. So no, it was not in any way deliberate. I think it kind of goes back to the fundamentals point that I mentioned. So I double majored in computer science and biology originally, which explains all the biology books and chemistry books and et cetera, because I was really passionate and really excited about the Human Genome Project. I thought, it's like a book, right? Like you should be able, like, we are, the nature versus nurture debate aside, like our DNA makes us who we are. I should be able to just read these 23 chapters and be able to say something interesting about people, and that's really fascinating. Like
the AlphaFold must made you pretty happy.
Yeah, yeah. And so I was smart enough to understand, and I think that's actually what matters less. I think most people are actually more than smart enough to do this. I don't think I'm actually necessarily a smart person necessarily. But I was kind of willing to ignore what people said is possible or not possible. And it's like, hey, I want to do this, and to do this, I need to do X and Y.
Right.
And X and Y in that case happened to be biology and computer science. Um, and so it was not deliberate. It was deliberate in like a very short-term sense. It was not in any way deliberate in like hey, this is what I want my career to be in like 40 years kind of sense.
But then how did you decide to pick, which one to focus on and learn?
I hated biology. I
Interesting that you majored that, but
yeah,
maybe
I mean,
after going through that, you don't like it.
yeah, very much. I did not like. I had ADD. I have always had it, et cetera. And so like part of a lot of my career, a lot of things I mentioned are kind of representative ADD-ish traits. Which is to say, like, if I'm excited about something, I'm all in. If I'm not,
Right.
it's just not going to happen, basically.
Right.
Even if it's like hundreds or thousands of dollars worth of finance or whatever. And I had the courage to kind of believe in that I could kind of fill in the blanks regardless of whatever I wanted to do. And so biology, yeah, like I thought the subject material was interesting, but I hated like I did not want to spend like hours at a lab, and given my ADD-ish personality, make stupid mistakes and like, oh, I pipetted 15 millimeters as opposed to 13 millimeters, and now the entire experiment is ruined. I have to redo this for like 7 hours. Just was not appetizing to me. Whereas like with code, it's like, oh, hey, I made a mistake. I can just re-edit this and rerun it again. It's fine. It's not a big deal. And so that was quite an obvious decision to me. If I look at it back in the career, then so this is where like anyone who tries telling you it's like, hey, I had this master plan, it was all great, you should treat that with a very grain of salt. If I look at it kind of like what I have learned a lot of different things, and I've been able to stitch those different things. I think what it fundamentally goes to is this notion. It's called in neuropsychology. It's called this notion of neuroplasticity.
Mm-hmm.
Is that you learn how to learn different things, and your brain realizes that hey, what matters is less the specific details of whatever it is I'm learning, but rather the fundamentals, and like being able to adapt to different things. And so, as a result, I think fairly directly of like studying both computer science and biology, and also philosophy, which is further down on the bookshelf. I kind of like learned that in a formative way fairly early on. And so like now, if I look at my career, I've done everything from computational biology to e-commerce to real estate to education to employment. There's a whole bunch of companies in between that are advisory, like Airbnb is like, real like the tourism industry, right?
Yeah.
And so the fundamentals of machine learning, certainly, but even like of how people behave doesn't really change between any of these things. And so if you can get to the core of, let's say, biology, if you can like tease out how things behave and things work, how people behave, these things end up being very useful downstream in often non-obvious ways.
Yeah. It's like transferable knowledge. Yeah, and you start seeing like the insights inside of it. Okay.
Yeah, I would push it even further. So like for every book I read, I try to remember one thing. I have a terrible memory. So it's just literally like I can read a 400-page book and it's like, all right, here's one fundamental concept I need to remember from this. And then I can remember enough to go look the book back up, but I don't have to remember like, hey, this theorem proves this theorem in this way, and here's the details of the proof. Yeah.
Awesome. Okay, so I can see there's quite a few people ask questions in the chat. But instead of you ask in the chat, I would ask you to maybe raise your hand, tell Kusha which city and state you're from, and then talk about your question. Okay, and you don't have to. I mean, just raise your hand. I can actually see your hands. Just raise your hand, and I can just call your name. Okay. All right, Jackson, please go.
Okay, so I'm Jackson. I'm from San Jose in California. So I was wondering, so obviously like technology, it's going to advance further and further as time goes on. And it seems like like a pretty fair amount about it. What problems do you kind of see that could arise from that advance in technology? Like, is there anything that's obvious? And like, how
You're asking the crystal ball question.
Sorry?
You're asking the crystal ball question. No, but seriously, like, you're saying like, hey, in like 5 years, like what might technology enable given the trajectory of technology, basically?
Yeah. I mean, and it seems
Yeah.
like you're pretty well invested in on the in AI and stuff, and it seems like that's going somewhere. So like,
Yeah.
I don't know. Is there
That's a
anything?
really, really tough question. If I could answer that, I'd actually still be doing what I would be doing today, but like, you know, people spend billions of dollars to try to answer that question, right?
Yeah.
I can speak to some trends that I see, and I can speculate of what might happen, but obviously no one knows is the short answer, right? So I think automation is a thing. So things that we thought only humans could do 10 years ago are now being disproven at an increasing rate of what turns out computers or robots can do on an automated basis, which I think will have fairly profound consequences for our economy, what jobs exist, what business opportunities are. So what do I mean by that? So, 10 years ago, computer vision was really, really hard. It would take PhDs, half a decade, and people spent decades on this before, up until like, let's say 5 years ago, where people were like, oh, hey, I can look at a picture of a cat and tell you it's a cat. Like, that turns out to be a really, really hard problem. Was a really, really hard problem. And now it's actually relatively easy. People can do it all the time. Now the problem becomes like, how do you do this on video? How do you do this at a rate that's good enough for self-driving cars? Because again, this is the 4 nines. Like, you only get to hit so many people with your self-driving car before it's outlawed. So you need like 5 nines, 6 nines correctness, basically. If you're wrong in the wrong direction, people get irritated why you're driving 40 miles an hour instead of 45, and you try to explain like, I don't want to run over the poor grandma. Like, that seems better, but people aren't going to be satisfied with that answer. So you have to get really, really good. However, it's going to take longer than I think folks thought it was a couple of years ago, but it's clear that the automation is it's going to happen. Other examples of this is that, there are now roboticized waiters that are coming out. They're roboticized check-ins, and this is going to fundamentally change the fabric of American and global economy. And I mean this in 2 ways. Right now, a lot of that research of what's possible to do is locked up in PhDs' heads. But if you stitch it together with like what 4 nines computer vision looks like, plus sentiment analysis, it means all of a sudden you can basically start automating massive tracts of the service sector. And what does the world look like where half the waiters, baggers, order, like receptionists, so jobs don't exist anymore. Those are replaced by robots.
Truck drivers. Yeah.
Oh yeah, I didn't even, like truck drivers, cab drivers. Like, the world is going to look massively different. Just playing on the truck stop case, right? Oh, the truck driver case. You don't need truck stops if it turns out like 80% of your drivers are robots. You just don't need truck stops anymore. So like, that has like massive downstream effects of like what the economy looks like. Now, this is probably not going to happen in 5 years, but is it going to happen in 50 years? Probably. So I have a young daughter. She's like about to turn 2, and if I think about what I'm going to nudge her towards, it's like, look, I don't know about any one skill. I don't know about any one problem, and I can't predict on her time scale, which is 50 years out, what's gonna happen. What I can predict is like, I believe this automation thing is a real thing. It's just a fact of life. It's going to drive massive unemployment. It's going to change the problems that matter. It's going to change how businesses operate, et cetera. In which case, what really matters, in my opinion, is math and empathy. Like, the service sector is not going to ever completely go away. Empathy really matters in running teams. It really matters, and this is the matters in like interacting with people. Like, we are social creatures. You have to know empathy. You have to be empathetic, rather, and math. Like, I think a world where 30 years ago that you could sort of like get by as a salesman or woman, just by being really good at it, is like you still have to now all of a sudden, even if you're a salesperson, you have to like understand how funnels work, which is fundamentally a data analytics question, etc. So I would, if it were me, I would bet on automation as a specific trend that's going to create a bunch of different problems that matter.
Yeah.
If it were me, I would bet on empathy and math to be uniquely positioned against this massive trend.
Well said. Well said. We even think like teaching eventually will be replaced by AI. So that's something.
Yeah. Yeah, I have lots of personal opinions about that, but I think it is clear that I think there will be a lot of assistance coming from automated providers of education.
For sure, for sure. Chloe, you had a question.
Hi, yeah, I'm Chloe. I'm from like the Bay Area, but I go to school in Connecticut. But I had a question, like as a high school student, and I'm assuming a lot of the other kids on here are high school students too. Like what was one of the classes that influenced you the most, would you say? Like there's so many things you can learn, whether it be like all the different coding languages, like there's so much available, but like what impacted you the most? Because as you talked about, like there's so much adaptability. You honestly, like in the future, I have no idea what realm of computer science or anything I might go into. So there's so many things you could know.
Yeah, I saw your question. I love the question, for the record. I was gonna pick it out either way. Again, I have a slightly atypical background, so I'll try to answer, I think, the intent of the question, not necessarily for me. The top level answer, though, is that it was my sophomore English class. The teacher's name was Miss Yamaguchi. And there's one line that she mentioned at some point in the year that just stuck with me, which is like, I don't care if what you think you wrote was clear. If it's not clear to me, as your reader, it's not clear. You as a writer don't get to decide what's clear. I as a reader get to decide what's clear or not, right? And especially, I think, in technical fields, people grossly underestimate the importance of writing. It doesn't matter if you came up with the amazing analysis. If you can't explain it to someone, no one cares. Like, it's just like, certainly in a business context where everyone's really strapped for time, but also in general, like if you can't explain it, it just doesn't matter. Like Einstein could have come up with, if you couldn't explain it, it just doesn't matter. And I think, Miss Yamaguchi just had that one pithy summary, like that stuck with me, like 20 years later now. So if I had to pick one class, it would be that. But I don't think that's the real intent of your question. I think I would say, to answer the intent, as I understand your intent, I think it goes back to this point about fundamentals. So I would absolutely not, like, if you have an option to take like 5 programming languages, don't. It's just not worth it. Learn one, learn to understand why it works, understand how like it enables certain things. But to the extent that you can understand, like, let's say, just using that example, the programming language, understanding one programming language is super important. Understanding how computers work, like really kind of understanding it in a deep way, understanding how data structures work, understanding how algorithms work. So like, go deep and to understand the fundamentals as much as you can. And at that point, the question becomes like, how many different fundamental concepts can you learn? If it were me, I would pick psychology. I would pick statistics. I would pick just one computer science thing, like go deep again. All these matter, that you have to get to the fundamentals. Writing, certainly, communication is certainly important. But yeah, I would, like, if you abstract out what I said about the book, right? Like each of these books, I literally learned one thing from, maybe 2 or 3 if it was really, really important to me. But like, if you think about your life as a collection of what are the fundamental concepts that you've learned, I promise you will be able to apply them in new and powerful ways for whatever it is that you want to achieve. And what everyone wants to achieve is different, but like, you need to like over time collect those fundamental concepts. Mm-hmm. And that, I think, is, if I look at what I've done in my career, it's fundamentally that.
Yeah, it's a great answer. It's a great answer.
Thank you.
All right. Anybody else got questions? Raise your hand. Granit, you had a question, right? You wrote it.
Yeah. So my name's Granit. I'm from California. So since AIs will get bigger over the years and more advanced, like let's say a couple of decades from now, AI will be very advanced. It might start taking more jobs, like besides just driving or robotics or stuff. So
Yeah.
how do you think the world would like react like when AI takes over a lot of jobs? Like how would people like earn money because they can't find available jobs?
Yeah.
Grenade, how old are you?
I'm 11.
Yeah, 11. Okay. Are you the youngest student at AI camp?
I'm
Probably,
not
right?
sure. I
Yeah,
think in
you're
my
there.
class,
Yeah.
there's probably someone younger than me. I don't
Yeah,
know.
there's a 10-year-old. Yeah. Okay. But you're at the younger side. Okay.
Yeah, that is a really hard question, Praneeth, and I think it's a really great question for anyone, but especially an 11-year-old. There are people who are far, far smarter than me, and they're trying to figure out how to answer that question, just that question, and they probably spent years of their life doing it already, and probably will need to spend years more. I can guess what the answer might be, or what the shapes of the answer might be, but I have no idea. It's a short version. I think given automation, given exactly what you're describing, I think a few things could end up happening. One answer is this notion of universal basic income that I think a lot of people talk about, but don't really have a good sense of yet. I think I could imagine a world where work weeks get shorter. And so instead of working, I work hard, I work, like let's say 50, 60 hours a week, or more probably. Maybe that's not the norm anymore. Maybe the norm is now 30 hours a week. So now you can spread the same amount of work across more people. I think another part of this is probably regulation. So there might be things that we just don't want robots doing, or we want people to be involved in different ways in doing them. I think what's really important to note here is that like this isn't just about money, right? Like I think people, it's a question of money, it's a question of trust, it's a question of do we like trust a robot to do this thing? I think it's a question of pride of work. I think a lot of people, including myself, don't necessarily work. Like, sure, the money is important, but we work because we love what we do and we want to feel independent and empowered and take pride in what we do. So it's a really, really complicated question. If I knew had the answer, I would again still be doing the same thing, but it's a very hard question.
Do people still will have to label data?
Sorry, can you repeat that, Michael?
Sorry, I was just joking. Sometimes we have a project and students, they have to label a lot of data, and there are certain times for example, like we have students like spend 15 hours in the last 24 hours labeling data. So
yeah, you'll probably still have to do that.
Yeah.
Maybe less, but
maybe less. Yeah, hopefully. Guys, time's up. This really flies through, right? So we didn't even get to, for example, the Opendoor, where Kushal is helping right now. We didn't even get to Airbnb, all these famous companies, but hopefully we learn a lot during this whole process. Can we please give Kushal a round of applause? Just show our appreciation or respect that you're here, helping us learning all these things. We really appreciate that. Yeah.
And thank you. Like, I love the questions. Michael, thank you for putting this together. Like I said, like I wouldn't be here without my teachers at every stage. And